Hello, GAC Spartans. This is Coach Johnson, all the way from Norcross, Georgia, and coming to you live. Hope you're having a great day. I know I keep getting Twitter uh, people contacting me wondering if I really am the Mr. Tumnus on the Chronicles of Narnia, and so thank you again for being such a loving class and for spreading that rumor even further. So thank you very much. All right, let's get started with tangent. We've already done sine and cosine within our trigonometry graphs, and now we're going to go into tangent and cotangent. Now, when we do these, the graphs do look different, but again, very similar to how we found sine and cosine. All the amplitude, period, phase shift is the same thing that we're going to do with tangent. All right, let me show you what I mean by that. First off, what we want to do is, in order to find what our asymptotes are within our tangent graph, let's first understand what a regular y equals tangent of x graph looks like. Well, first of all, we start on the right side, and again, these graphs could be any way you would have it. I'd probably make it a little bit bigger, but just to show you the pattern, is we create dotted lines to the right and to the left. In fact, at these points in a traditional graph, the to the right is positive pi over 2, and to the left is negative pi over 2. So if I went again, since between the two asymptotes is pi, our period for y equals tangent x would be pi. That's very, very important. Remember, sine and cosine is 2 pi, whereas tangent of x, again, traditionally, will end up being just pi. So again, if I were to repeat this, I would do it over and over again. This time, if I added pi, I'd have 3 pi over 2. And obviously, if I did on the left side, I'd have negative 3 pi over 2. So notice, again, within a regular tangent of x graph, it would be pi over 2 to the right and negative pi over 2 to the left. Now, once I get to the middle here, in order to create our tangent of x graph, it's almost as if we're creating a parabola, except one side is going to go up, one side is going to go down. Now, again, we're talking about a tangent of x graph that's positive. So what we do here is we rise to the right, that approaches the asymptote but does not cross, and falls to the left. Now, again, if this is negative, what would happen would now be, it would obviously shift. So instead, it would fall to the right and then rise to the left if this was negative. But now we obviously know it is positive in this case. So if it is positive, we continue. And again, it just repeats itself, rising to the right and falling to the left, just like so. Okay? Now, a couple things to note with this graph that's important. First thing is, obviously you could see that when I rise to the right and fall to the left, this is going to keep repeating to the right as well as to the left. But also notice that as I do this, there's also going to be something that comes up where you have to figure out, okay, where's this x-intercept? All right, well, the x-intercept is always between the two asymptotes. So notice that this one is in the origin. This one would be kind of over to the right side a little bit more, between pi over 2 and 3 pi over 2, and so on the other side. Now, again, when the period shifts, it may, or the phase shift or the period changes, that may change just a little bit. But just to give you an update on that, that's very important. Now, in order to find the amplitude of something, it's important to note that what I like to do is find a point that is 1/4 between the asymptotes and 3/4 between the asymptotes. So as I look at this, let's look at this one right here. And again, I do this to all the ones that apply. If this is in the middle, we know that our points are for 1/4 and 3/4 is right here and right here. Meaning that at these points, my amplitude will be applied to that. So again, I'm going to erase this stuff on the right side because you know all of this stuff is going to be repeated. But just so that you could see what I'm talking about. If I were to take, and I'll use green here, if I were to take the green and at 1/4 and 3/4 of this, I have to figure out my amplitude. Again, the amplitude is the value that's in front of tangent of x. In this case, it's 1. So from the 1/4 and 3/4 mark, it should be at 1. So right here, it should be up 1. And to the 1/4, it should be down 1. Okay? Well, let's pretend that instead of y equals tangent of x, we had y equals 3 tangent of x. Well, now no longer will it be at 1 going up, but at the 1/4 and 3/4 mark, it's going to be at 3 and negative 3. So now this graph is going to look a whole lot skinnier Again, still approaching, but a whole lot skinnier there. Again, the same thing is true if I had 1/2. Obviously, it would be a whole lot wider. If I use black, this 1/2 would end up taking it out a lot further, like so, and would then create, that would change that amplitude there. All right, so again, it's very important that as you approach this, it's important to note that the amplitude changes and needs to be applied to the 1/4 and 3/4 mark. Now, to solve for our asymptotes, we need to make sure we first figure out what is being asked. So in this specific one, to find our asymptotes, we always know that bx minus c and bx minus c equals pi over 2 and negative pi over 2. And what we're trying to do is solve for x. So in this example, let's say tangent of pi x over 4, we first note that b is equal to pi over 4. So b is equal to pi over 4, we then say pi over 4x minus c, in this case it's minus 0 because there is no c on the outside. And we know that that equals now negative pi over 2. And obviously pi over 2, but we're going to get to that in just a second. So since there's a 0 there, we cancel that out, leaving us with pi over 4x equals negative pi over 2. Well, to cancel this out, to cancel that x out, we're going to multiply by 4 over pi on both sides, 4 over pi. Pi's cancel on top and bottom, leaving me with negative 4 over 2, which then equals negative 2. So my first asymptote that I've got to come up with would be at negative 2. So I come over to negative 2, and I create my asymptote at negative 2 there. Again, it doesn't have to be physically at negative 2. It's relative to what it's being asked there. All right. So now, since that's at negative 2, we now figure out, all right, what's bx minus c equals pi over 2. So we do the same thing. We have pi over 4, x equals pi over 2. We multiply by 4 over pi. Obviously, you see this, and we end up getting 2. So at 2 and negative 2, we would have asymptotes, and it would keep repeating every 4, because in between here, from negative 2 to 2 is 4. The next one I would have would be at 6. It would come down, and negative 6, and so on and so forth. So again, that's how we would figure out what our asymptotes are. I then find the middle point, okay, middle point. And since I know that at our amplitude is 1, so our a is equal to 1, we know that from 1/4 and 3/4, these two dots right here, it would go up to 1 and negative 1, because we know it falls right, or rises right, falls left. So we go up, down. So we should have a graph that looks like that. Okay, up and down. And obviously you could do it again on this side, because we know we have one at negative 6, and it would just keep going on and on and on. Okay. All right, real quick. The same thing is true with cotangent. The only difference with cotangent is that to solve for the asymptotes here, you have to have bx minus c equals 0 and pi. The reason why that's the case is where tangent is here and here. Now, cotangent is now going to be from the origin, or from the, I should say, the y-intercept to pi. So from 0 to pi, okay? And then obviously it'd go to negative pi, negative 2 pi, so on and so forth, okay? With this one, though, with cotangent, it rises to the left and falls to the right. Again, unless it's negative. If it's negative, obviously it flips that, it changes that, flex it. But overall, that's how we approach this problem. So let's give a for instance here. Let's go this one. Let's do one example, and then after that, I'll be done for you. Okay. So real quick, we know that our a is equal to 1/2 for our tangent, and so since 1/2 is our tangent, we know that's our amplitude. We also know that in order to find what our asymptotes are, we take our x minus pi, and we set it equal to pi over 2, and we have x minus pi, and set it equal to negative pi over 2. So I add pi on both sides for both of these. Remember, get a common denominator, so if I put 2 on the bottom, I have to put 2 on the top, and same thing is true here. So what I'll end up getting is should be pi over 2. So I have x equals pi over 2. Over here, I have x equals 3 pi over 2. Now this changes up a lot because now I come here and let's say this is pi over 2. And we'll say that this is pi. And we'll say that this is 3 pi over 2. We're just adding a half into each one. So now what we have essentially is we have one at pi over 2 right here and one at 3 pi over 2. Again, because of this, now I can basically just do the same thing on the other side. Every 4 spaces here it ends up being negative pi over 2. And then over here we'll have negative, this is negative pi over 2. The next one will be, hold on real quick, just want to make sure. Yeah, it should be negative pi over 2. And then after that it should be negative 3 pi over 2. So now here's the question. Now we find the middle points. Okay, we know it's going to rise left, fall right, but then I come to my 1/4 and 3/4, and I know it's going to rise up 1/2 because that's our amplitude. So it's going to be a little bit smushed down a little bit. So because of that, it's going to be wider, and it rises right, falls to the left. Again, if it's negative, it flips that there, or if it's cotangent, obviously. Same thing here. It should be a little wider there, a little wider, and we know that it goes just like that. Repeat it, and we're good to go. Okay. Again, cotangent. Real quick, we know that because of this, our amplitude is 3. A is equal to 3, and we know that AX. I'm sorry, not AX. I don't know what I was thinking. BX plus pi over 4 equals 0. And bx plus pi over 4 equals pi. Okay? One thing I want to note real quick when I come to something like this is to note that whatever our c is, you've got to make sure that in this example we just take c down. Okay? Because again, we're solving for that. That's why we're taking it and running with it. All right? So again, coming with it, bx plus pi over 4 equals pi. So in this case, we have no b because it is equal to 1. So I subtract pi over 4. So I should get x equals negative pi over 4. And if I subtract pi over 4 here, remember get a common denominator. I should get, if I subtract pi over 4, I should get a 4 on the bottom and a 4 at the top. So it should be 3 pi over 4, again common denominators. X equals 3 pi over 4. So I should have negative pi over 4 and 3 pi over 4. Okay? So what I will do is this. Let's go each one. Let's go negative pi over 4 is here. And 1, 2, 3. We'll put 3 pi over 4 here. So we'll say each one of these is pi over 4. That'll be our graph, kind of where our coordinates are at. Okay? So again, we just keep adding, obviously, 4 to the left, 4 to the right. And now let's go forward with it. So now I've got my asymptotes here. Remember, it creates a crack in the graph. Okay? No laughing, please. This is not a joking matter. Some are small cracks, some are big cracks, but it does create a crack in the graph. All right? All right, so now, again, I find my middle point. Boom, boom, boom. I then find 1/4 and 3/4. That becomes easy right there. 1/4 and 3/4 of there. And then finally, I know that my amplitude is at 3, so we're going 1, 2, 3. So it's actually going to be pretty high, this one is. Except remember, it's not going to rise to the right, fall to the left. I actually did that incorrectly. Let's go to the left side, and then it's going to fall to the right. Rise left, fall right. Rise left, fall right. So finally, I should have something that looks like, and I know it doesn't even look like one. Maybe this one will be easier to draw here. I'd go down here. Come on. Again, as you could see, it's obviously not as, that's a lot better one right there. That's perfect. That's third one's exactly right. So again, it rises to the left, falls to the right for our cotangent, and then we're good to go. Again, I hope this made sense to you. Please make sure if you need to, watch the podcast, go over previous things that we had discussed. Other than that, have a great day, and I'll see you all later.